In this example, we're looking at unemployment rates in a certain location, Wichita, Kansas, compared to the national average. And when we run this, we're running a one proportion hypothesis test here. And I can tell I'm running a one proportion hypothesis test because A, the question asks for it, but B, because in reality here, I have a proportion. I can tell because it's a percent. I have one sample of 5,000 people, and I want to prove something, so it's got to be a hypothesis test. Having all that information down, I need to go ahead and start with step 1. Step 1 is list. I need to list p hat, n, and p naught. P hat here is the 5.1% from my sample. I write it as a decimal every time. N is 5,000, and p naught is what I'm comparing it to, which is 0.097. Now that I've got that, the second step is hypothesis. When I write my hypothesis, I have h naught, my null, and HA, my alternative. H naught is what I assume, and it's always P equals P naught, or P equals 0.097. That's not what I'm trying to prove, though. I'm trying to prove that the national employment rate of 9.7% is different than that of Wichita. And anytime I'm using the word different, that means greater than or less than, just not equal to. So I've got that. Step 3 then is to go ahead and find my test statistic. Having my test statistic means I need to find SE, and then I need to find my z-score. SE is square root p naught, 1 minus p naught, all over n. In this case, that means I need to use that 0.97 instead of the 0.51. Which gives me an SE, once I've calculated this, of 0.0042. Notice that's a really small SE, and it's a really small SE because I've got a large sample size. Now I've got that, I need to go ahead and find my z-score. My z-score is always my actual, which is 0.051, subtracting off my expected, 0.097, divided by my SE. I'm keeping 4 decimal places here because I'm dealing with proportions. Having done this, my z-score will be negative 10.95. After I've got all that information, the next step is to find my p-value. To find my p-value, I'm going to take into account the fact that my z-score is way off the table and it's way over here on the negative side. This is negative 10.95. But because I'm dealing with a not equal to over here, that means that once I find one side, I'll have to go ahead and double it to get a 2n tail hypothesis test. Now, in reality here, this doesn't matter a heck of a lot because my z-score is so big, it's not going to be on the table. Whenever it's not on the table, we say our p-value is less than 0.0002. Now, because it's two-sided, I'll go ahead and I'll double that. So one more time, I'm saying it's less than 0.0002 because it's off the table. And I am doubling it because it is not equal to. So in reality here, I'm going to have a p-value less than 0.0004. Notice that doesn't actually change my conclusion, right? Because once I come down here to step 5, I need to go ahead and compare that p-value to 0.05. Well, my p-value is less than 0.0004, which means it's definitely less than 0.05. And if my p-value is less than 0.05, that means I'm going to go ahead and reject H naught. I reject H naught because there's enough evidence. Our statement will be, there is enough evidence to conclude that the unemployment rate in Wichita is significantly different than that of the national unemployment rate.